Climate change today is often represented as a technological challenge. Every day, we discover new businesses presenting climate-friendly technologies to reduce our greenhouse gas emissions. It gives us a sense of calm knowing that major financial institutions promise to only invest in climate-friendly companies, to see the vast renewable energy projects in countries such as China, and to see the financial successes of entrepreneurs such as Elon Musk. These initiatives strive towards the critical target stated in the Paris Agreement of keeping the average global temperature increase below 2 degrees Celsius. To achieve that, we need to halve net emissions by 2050 and get to zero by 2070 at the very latest, if not much sooner. And in addition, we need to reduce the concentrations of greenhouse gases in our atmosphere. This video will look at whether technologies indeed can help us meet that 2 degrees target and what it means if we do not. Let's look at our emissions by sector from 2016, when we emitted around 50 billion tons of CO2 equivalent greenhouse gas emissions. These emissions come from a broad range of technologies touching upon every part of our urban industrialized economies. What is hidden in this graph is that half of the emissions assigned to industry come from electricity and heat produced by power plants. Similarly, most of the 17.5% of greenhouse gas emissions assigned to buildings also comes from power plants. In other words, if we are looking at what technologies are needed to reduce emissions, we need to see power plants as the largest source of greenhouse gas emissions, at 27%. Almost every technology behind urban industrialized society causes greenhouse gas emissions. Technologies for increased food and energy production and for construction and transportation all create greenhouse gas emissions. These are unintended byproducts, but byproducts all the same. Scientists tell us of disastrous consequences of breaching a 2 degrees Celsius increase in average global temperatures, including mass extinctions, increased natural disasters destroying lives and property, crop failures, and mass migrations of people. If we understand the Great Transition to be inevitable and still wish to prevent climate catastrophe, we need to change the technologies behind almost every aspect of the Great Transition. The question is, can we? Throughout the course, we have shown that it took the first wave between 150 and 200 years to develop the technologies for the Great Transition, which were then used by each subsequent wave. Hopes for zeroing emissions are based on the belief in a miracle that humanity will be able to make a series of technological revolutions in the next 30 to 40 years, developing new technologies and replacing existing ones, and doing it on a global scale at a time of rapidly growing demand. Developing new technologies will take time. Moreover, while some technologies are available, it will take decades for those technologies to mature enough to meet the huge growing demand in the third and fourth wave and replace existing infrastructure in the first and second waves. And for almost half of emission sources, we have no idea of how to replace them. Suppose we take steel and cement as an example of two core materials essential for urbanization. Together, they account for over 10% of our global emissions. Today, there are no existing scalable means to decarbonize steel and cement. If we take steel, hopes for reducing greenhouse gas emissions are pinned on shifting from coal to hydrogen. But industry experts estimate that the global steel sector can only reach net zero emissions by 2070. Similarly, cement today cannot be made without greenhouse gas emissions. Yet, over the next 50 to 80 years, we will see 6 billion more urban dwellers, more than doubling today's urban population and requiring new buildings and infrastructure. So, in terms of steel and cement, it looks as if our emissions from these technologies will not decrease to zero, but double. Or we can look at the source of 20% of emissions: food production, deforestation, crop burning, and other forms of land use change. Meat and dairy alone almost equal the emissions of all passenger cars. We can now see technologies emerge, such as Petri dish meat, and while these technologies may be exciting, they are truly early stage. Beef has scaled to meet an ever-increasing demand for safe, nourishing, affordable, and tasty protein. Even the most bullish pro-cultured meat analysts expect artificial meat to outsell real meat only in 2040. By then, as we showed in our food video, meat consumption will have doubled, meaning that, at most, emissions from cattle will remain stable and not decrease. We must wait to see if these optimistic predictions come to fruition, and alternative meat can scale production to meet the growing demand for protein competitively. Nor do these meat alternatives do anything to solve nitrogen emissions from increased fertilizer use or deforestation to allow more space for crop cultivation. So again, we can expect agricultural emissions to increase. Road transportation accounts for around 12% of emissions, specifically passenger cars at 7% and trucks at nearly 4%. Today, there are around 1.3 billion passenger cars in the world, and most experts project that there will be 2.5 billion by 2040. We also understand the source of this growth. Second-wave countries still have far lower numbers of passenger cars per capita than in first-wave countries. Today, electric cars are a trendy topic in environmental discussions. Tesla, in particular, has captured the public's imagination with its promise to transform the energy sector to become more renewable. But how quickly can it scale? Optimists expect electric vehicles to reach a third of sales only by 2030. In other words, as important as personal transport may be to urban industrialized living, we would have to dramatically increase production and decrease costs to meet the demand for 2 billion new passenger cars in the next 20 years and replace the existing billion as they reach the end of their lives. Not only that, but we need to transform the entire electricity sector. If all these electric cars are powered by coal power plants, then emissions would actually rise. Third and fourth waves already face rapidly growing electricity demand without increased demand from the transport sector. While electric vehicles may be part of a solution, they can, at most, play a 12% part, and in the next few decades, more likely a small fraction of that. This means transportation emissions also will rise, not fall, and certainly not fall to zero in the coming decades. Let's turn our attention to renewable electricity production. We can see a great deal of discussion about solar electricity's falling costs and significant investments in renewable electricity production. However, we need to remember two things from our energy video. Firstly, no first-wave economy has a 100% renewable electricity system, and all of them built their grids initially based on coal, and then coal and gas. Considering the challenges faced by the transition to renewables in first-wave countries, it is not surprising that studies show the fourth wave sub-Saharan Africa's electricity capacity will not only double by 2030, but that renewable energy sources such as wind and solar power will make up less than 10%. The technology is not ready for the massive scale required. And secondly, even if it was, electricity makes up less than 20% of energy consumption. For these and similar technologies to bring our emissions to zero requires nothing short of rapidly rebuilding the entire infrastructure of first and second wave countries and finding an alternative way for third and fourth wave countries to develop an even larger infrastructure, when the existing blueprint took almost 200 years to develop. Realistically, scaling this technology will take decades, and we have only 30 to 40 years to achieve this unprecedented transformation. We may see China announce 1 terawatt of renewable electricity capacity, but they already have 1.7 terawatt of mainly coal-based electricity capacity to meet their need for 3.3 terawatt in 2050. That is, coal will form 40% of their 2050 energy mix. Yes, new technologies are appearing, but it is not enough to simply trust in the exponential nature of developments in technology. Even the optimistic among us must understand the scale of the challenge if we are to achieve such optimistic goals. Moreover, there are so many sources of greenhouse gas emissions that need our attention, and the media, investors, and public simply cannot keep them all in mind. We may hear about artificial meat and electric cars, but do we hear about businesses fighting fugitive emissions? Just in case, fugitive emissions are those emissions caused by leaks or wasted fossil fuels in the exploration and transportation of oil and gas. They account for 5.8%. Another 7.8% of emissions come from so-called unallocated fuel combustion, more than all passenger cars. These hard-to-combat emissions do not get the same attention as passenger cars, but are just as serious. An even more troubling concern of the author of this course is that our focus on technologies blinds us to the real issues at hand. Implementations of the Kyoto Protocol focused more on building emissions trading markets and lost sight of the key goal, which was decreasing greenhouse gas emissions. Similarly, focusing on the technologies and business opportunities in the consumer goods sector may result only in a great electric car market, but no closer to fixing the climate. If all that was not challenging enough, we should also consider that we are not certain about how humanity is damaging the climate. As discussed in the previous video, another entirely scientific explanation is that the destruction of natural forests and their biotic regulation capacity is to blame. In other words, to be confident of success, we would not only need to reduce our greenhouse gas emissions rapidly to zero, we would also need to ensure that no more natural forests are destroyed, while simultaneously setting aside vast areas of land for the decades-long process of natural afforestation. Otherwise, we may find ourselves in the position that we have achieved a near impossible goal and not prevented climate disaster. For these reasons, suggestions that humanity should use geoengineering to regulate the climate sound very concerning. Some who recognize that our economies cannot be decarbonized have called for technologies to cool the planet directly, including limiting sunlight. One idea gaining momentum involves pulling tens of billions of tons of carbon every year out of the atmosphere and storing it underground. Yet the idea that we should interfere more and not less in our climate, a climate we poorly understand and have already broken, sounds to many others as if we would simply be creating new and worse problems. We do not know what would happen if we suddenly start extracting billions of tons of carbon out of the atmosphere. Moreover, there is the long-term risk that the underground storage would leak and lead to trillions of tons of carbon released rapidly into the atmosphere. These types of debates are likely to become ever more frequent. At current rates, we will have exceeded our carbon budget to go below 2 degrees within the next 20 to 30 years. So, if technology cannot save us, can we force everyone globally to throw away the keys to all their cars, turn off our power stations, and eat poorer diets? If not, we need to accept that 2 degrees is inevitable. 4 to 6 degrees Celsius looks more likely. What does this mean? It means that in the 21st century, and most likely in the 22nd century, we will be living through a period of ever greater climate instability. Our societies and economies will be increasingly impacted. This and other pressures from the Great Transition may indeed bring us to civilizational collapse. Perhaps not in our lifetimes, but certainly in the lives of our children. So, humanity will undoubtedly need to become more resilient. Decarbonization is by no means a pointless exercise, far from it. Achieving a 3 or 4 degree increase rather than a 6 degree increase may be the difference between human civilization survival or demise. We don't know that, but we can hope. For those who understand the full scale of the challenge and are not wildly optimistic about our chances of preventing climate catastrophe, the question remains, what should our goal be? Understanding that the next few decades will see ever more visible and damaging climate change does not mean we should do nothing at all. It simply means we should be informed, not naive activists. The next video will provide some thoughts on what can be done.